All right, let's do this bad boy in pieces. Let's do this first part. Let's determine the electrical force. We've got a coulomb, we got distance. We're ready to roll. Let's tear it up. Force electric equals K, Q1, Q2, R squared. My K is 9.0 times 10 to the ninth. Newton meter squared, Coulomb squared. My first Q, I'll just use the first one they give me, negative 1.0 times 10 to the negative 6. And the second one's 4.0 times 10 to the negative 6 coulombs. And we should have a distance in there of a half a meter. But what do you do with distance? Square it. Yes, square it. Very good. All right, to the calculator we go. 9 EE 9 multiply 1 EE negative 6 multiply 4 EE negative 6 enter divided by 0.5. Be sure to square it. I'm getting 0.144 newtons. Okay? That's important for the next piece. Alright, so now they want us to take this picture, which I just put down here so I can use a little better. Draw a force diagram on this. Well, we know force of gravity goes down. Wasn't there a force electric coming up? And that equaled 0.144 newtons? We just figured that out in the last slide, or the last whatever. We just did that. Force of gravity, isn't that the weight? Weight equals mass times gravity. This thing has a mass of 30 grams. Now careful here, we got to get it to kilograms, which means we have to move that over 3, so 0.030 kilograms. Why did I make this so small? 9.8 meters per second squared. That's 9.8. You should know gravity at this point. So let's throw that in the calculator and tell us what the value is. 0.03 multiply by 9.8, and I get 0.294. 0.294, and that would be newtons. So I 0.294 down. I should keep these things on the same side. 0.144 newtons up. Okay? Will the balloon accelerate up, down, or where's the net force? Which one's winning, or are they equal? Well, to me it looks like the force of gravity wins, so it will accelerate. Okay, that was odd. Down. Why? Because this number is bigger than this number, and it wins. So it's going to go down, but it's going to be impeded a little bit. So if there is an acceleration, calculate its value. Well, let's go back to F equals ma, which turns into A equals F over m. And that's hard to see. So A equals, what force? What is the net force? Well, it's going to be 294 minus, 0.294 newtons minus, I'm getting sloppy here, gee willikers. Alright, A equals, my force, it's my net force, so let's go 0.294 newtons minus 0.144 newtons, and we can put a number there, and I could do that, 0.294 minus 0.144, and I get an overall force, remember this is force, I'm doing force over mass, of 0.15 newtons, and the mass of the balloon we just decided was 0.030 kilograms, so divided by 0.03, and I get 5 meters per second squared, and we'd say down. Hey, that was fun with a capital PH. Thanks for listening all the way through. I haven't given out candy in a while. We haven't done these in a while. Let's pick tape measure as the magic word to get you candy. Bye-bye.